Linked lists are a fundamental data structure in computer science. They appear everywhere. And now we'll learn how to implement them using Python's object system. So a linked list is either empty because it contains nothing, or it has the first value in some sequence and then the rest of the values in the linked list. So here's how we're going to represent the sequence 3, 4, 5. We'll use an instance of a class called link. I haven't defined that yet, but I will soon. And that has two attributes. First, which is 3, and rest, which is some object. Now that object is holding the rest of the values, and it itself is also a linked list, or a link instance. So every linked list has a smaller linked list as the rest of the list. So this link instance has its first value as 4, and the rest of its list is a link instance whose first value is 5. Now we've exhausted everything we're trying to represent, but we still need some rest attribute. In that case, we use a special value called link.empty. Link.empty is the exception to the rule I just said, that every linked list has a rest of the list. Link.empty doesn't have any first value or any rest of the list. It just represents the fact that there's nothing left. So the right way to think about a linked list is not this particular class with these particular attribute names, but as a pair of values. It's a first element of some sequence, and then the rest of that sequence. In this case, we're storing the first, actually the 0th element, as an attribute value. I call it the 0th element because it will correspond to index 0 once we come up with a way of indexing into this list. The rest of the list is itself a linked list, or link.empty, and that's stored as another attribute. So you can have objects that are values of attributes, and here we're using the idea of composition in order to construct an interesting structure. So a linked list has a linked list as its attribute value. Finally, there's some class attribute that we use for any linked list that's empty, and we call it link.empty. Now the way we construct this is not by writing 3, 4, 5. That would make a tuple. Instead, we have to write out the constructor. A link with 3, and the rest of the list is a link with 4, and the rest of that list is a link starting with 5, and the rest of that list is link.empty. So each one of these calls to link creates a new link instance. This call creates that instance, which must exist in order to make this call, which creates the linked list starting with 4 followed by 5. Now here, the order in which functions are evaluated in Python is important. In order to evaluate link4, link5, link.empty, we have to first evaluate this operand sub-expression in order to create the link instance that represents the sequence starting at 5, followed by nothing else. Once that's created, we can pass it in as an argument to this link, which starts with 4 and is followed by all this other stuff. And then finally we can evaluate the whole expression and build the whole linked list. Now these structures are so common in computer science that there are some conventions about how they get drawn. Typically you do draw them as a sequence of pairs with arrows like this, but instead of drawing an arrow to link.empty, it's very common to just put a slash there. This is not any sort of official notation, but you will see people do this out there in the world, so I thought I'd show you now. In our implementation, we're going to mirror this structure by making link.empty the default value for the rest attribute. And that means you can leave it out when you want to construct a linked list. So, We want this expression to actually evaluate to a link instance representing the sequence 3, 4, 5. And for that, we need a class statement. In the linked list class, we just have an init method, which takes in the first and the rest. So here's the class, here's the init method. As I mentioned before, we're going to have a default value for the rest, which is link.empty, which I haven't yet defined. The first thing we'll do is make sure that the linked list we're constructing is well formed. It follows the property that I said, that the rest of the list either has to be the empty list, link.empty, or it's an instance of the link class, meaning it's itself a linked list. So those are the only two things we're allowed to pass in as the rest of the list. And then we store the first element and the rest of the list as attributes of the instance self. isInstance is a built-in function in Python that returns whether rest is a link when passed these two arguments. If you ask for the help from Python on isInstance, it will tell you that it returns whether an object is an instance of a class or of a subclass thereof. So it's a little bit different than just getting the type of rest and seeing if it's exactly equal to link. This will also be true if rest is an instance of a class that inherits from link. And this is a good idea because now our system is extensible. If we want to build a special kind of linked list by inheriting from link, we can still use this same constructor, and this verification will still work out as we expect. So what is link.empty anyway? Well, here we have a choice in our implementation. I've chosen to represent it as the empty tuple, although I could have invented a special class just for the empty linked list. Instead, I just picked some zero-length sequence, because that's what it is. It's a zero-length sequence. Okay, let's see how it works. I can create a linked list with 3, followed by 4, followed by 5. If I call this S, I can start inspecting its attributes. S.first is 3, S.rest is 4, 5, which means if I want to get the element 4, what I need to write is S.rest.first, the first element of the rest of the list. I can access 5 by saying the rest of the list's rests of the list's first element. That's 5. And finally, I can ask whether the rests of the rest of the rest of the list is link.empty, and it should be, because there's nothing there. So these are the ways in which I'll manipulate a linked list. It is, of course, possible to change the values within a list. I could set s.rest.first to 7. Then, if I look at what s is, I find that it's 3 followed by 7 followed by 5. However, oftentimes linked lists are used in situations where you're not mutating the values. That's where they're specially designed for. So you can create a list that's similar to another list just by adding a different value onto the front. So if I want to create a linked list that starts with 8 and then is followed by 7 and 5, I would do that just by writing link 8 followed by the rest of the list. Writing this creates a new list, but it doesn't change the old one.